Hey, welcome back. So far, with these polynomials, we've worked with addition, subtraction, multiplication, and now finally we're getting to division. So section 5.9 is division of monomials for now. So to begin, let's review some rules of multiplying fractions. For instance, if we have 3 divided by 2 times 5 divided by 4, we solve this by simply multiplying what's in the numerator to get the numerator of the solution, multiply what's in the denominators to get the denominator here. And that gives our solution. Now remember, we can do the same thing with monomials that are divided. So if we have 2 over xy squared, we can rewrite this as 2 over 1 times 1 over x times 1 over y times 1 over y. Because when we multiply everything in the numerator, we get this numerator, and we multiply everything by the denominator down here, we get the denominator. And that's why we can split those up like that. And this will be very useful for when we're dividing by monomials. So if we're given something like 10 divided by 2, now we know that that's 5. But why exactly is that? Well, because we can write 10 divided by 2 as 5 times 2 divided by 2. And we can rewrite that as 5 over 1 times 2 over 2. And what's 2 over 2? 2 divided by 2 equals 1. So we get 5 times 1, so we get 5. Now it's no different if we throw a variable in there. Say we have 5 times a divided by a. We can rewrite that as 5 over 1 times a over a. And a over a, just like 2 over 2, is just 1. So 5 times 1, we get 5 again. Alright? Well, let's try some little trickier examples. What if we have a negative 4x cubed divided by x squared? We can rewrite this as negative 4 times x times x times x over x times x. And we can rewrite this then again as negative 4 over 1 times x over x times x over x times x over 1. Now again, x times x is 1, x times x is 1, so those just kind of go away. We get negative 4 times 1 times 1 times x. So we end up with negative 4x. Now, looking back at that same problem, when we rewrite it out again like this, we see that there are 1, 2, 3 x's and 2 down here. But instead of having to rewrite it all out again, like here, we can skip that and simply just cancel x's, because we know that their x over x is just going to be 1. And anything times 1 is just itself, so it's not going to really matter. So when we rewrite it, we can just simply cancel out these 2 x's, cancel out these 2 x's. And then that means we just have negative 4 times x in the top. We have nothing in the bottom, but we still have a placeholder, so it's still 1. We can't say it's 0 because we can't divide by 0. So we end up with negative 4 times x over 1, which is simply equals negative 4x, just like we got before. Okay. But what if I have a problem like this? Well, as with before, I know that a divided by a is just going to be 1, so I can just cancel those. Same with b divided by b is just going to be 1. So I can just cancel those. That leaves me then with 4 up top and 1, 2, 3 b's. And an 8 and an a in the bottom is all. So then I have 8a. Then I simplify that. 4 divided by 8 is just 1 over 2. 4 divided by 8 is just 1/2. And then I have 3 b's. So that becomes b cubed. And then I just have an a in the bottom. So then I just leave that as a. So then my final answer then just becomes b cubed over 2a. And that's my final answer. As with before, let's go see if there's a pattern to all this. So for instance, we see we have x cubed and x squared, and we ended up with x to the first in our solution. Well, what we see here then is that it's just simply 3 minus 2 equals 1. We got the 3 here, the 2 here, and the 1 was in our solution. So if we have something like this, 5a to the 7th over a cubed, if I don't want to write out 5 times a, 7 times, and a times a times a, I don't have to. I simply look at the exponents and subtract them. So I end up with 5a to the 7 minus 3, which just equals 5a to the 4th. And that's all there is to that. So now you have some tricks. We can cancel things as we did here after you write it all out. Or you can write it all out in a different form so that we see x over x and x over x to get us ones and simplify. Or we can simply just look at our exponents of our variables here and then subtract them to get our final answer. So give that a try and we'll see how it goes in the next video. Thanks.